MoDOT for the Champ Clark Bridge project. So we are excited to kick this part of our project off. We wanted to invite you here to help us with part of our project. And we'll explain what that is, but at the same time, we also want you to be able to understand and learn about the project as we're building it and constructing it. So our whole goal here is to be able to give you guys some information about engineering, about construction work, etc. But at the same time, we have a challenge for you, and I'm sure your teachers have talked to you about that a little bit, about how that's going to work, and we're going to explain that today. We're going to take a short little trip out to the park overlooking the bridge. You can see the old bridge. You can see some of the construction that's going on now, and we'll show you the location of where we are going to build this little structure that we're asking you to participate in the challenge. So just want to thank you for showing up. We are excited about the opportunity to have you guys participate. We look forward to working with you. So I want to introduce Michael Massman. He is part of the crew. He is one of the folks who works for Massman Construction. So if you don't make the connection, Massman, Michael Massman. So, but his company that he works for is the one who is constructing the bridge, and so he's going to kind of talk about the bridge itself, the construction, some Bridge 101, so you can understand components of a bridge, and just give you a little background on their company. So, Michael.
Thank you. Like Keith said, thank you all for being here. We really appreciate your guys' interest in the project. A couple things I'll cover: brief history of our company, brief history of our project here at Champ Clark, and then some bridge basics, kind of what goes into a structure like the one we're building here. Quick background about myself: first experience in the construction industry was as actually a laborer on the Bond Bridge, Cable Stay Bridge in Kansas City. Since then, I've been involved in a courthouse project, a light rail job, and now here on Champ Clark. So a little bit of everything. This is my first Mississippi River crossing. Definitely not the company's first, but it's an exciting project and one we're super excited to be part of. Quick history: company is 110 years old. We're founded right here in Missouri, headquartered in Kansas City, a big office in St. Louis, another office down in Louisiana. Our yard is here, or hours south of here in St. Louis, so we've been doing projects up and down the Mississippi and Missouri rivers for a very long time. Focus is on the inland waterways of Mississippi, Missouri, also on the Gulf Coast. You can see from the map we've done projects all over, but a good chunk of them are within a couple hours drive of right where we are here. Quick overview: some of our recent or current projects: Cable Stay Bridge in New York City, Basket Tight Arch Bridge in Little Rock, Arkansas, Marine Terminal down in Louisiana, so private sector work. Still a cool project. And some of the ones you guys might have seen: Stand Span, new Cable Stay Bridge for MoDOT, about an hour south of here in St. Louis. One that we're super excited to be part of, just because it is the third longest main span in the United States. Another one, if any of you have ever been to Mark Twain Lake, the reason that lake is there is because the Corps of Engineers built a dam, Clarence Cannon Dam, and that's a project that we spearheaded as well with the Corps. Other projects in the area where we'll talk about the current project, but we've done work rehabbing the existing structure, and then something I found out recently, actually, when I was looking into it, was the railroad bridge just right south of here. We did some work on back in 1912, which was earlier than I expected us to be in this area, so that was kind of cool. But the project we're here to talk about is the new Champ Clark Bridge. It is one that is a great example of kind of, these are the basic components of a bridge. One thing I always think is cool is if you look at the existing project, how much steel and concrete went into that versus this much more efficient design. Kind of shows you that even something like bridge building is continually evolving, pushing the limits of what's possible, and it's not just, hey, we're building the same thing twice. And that's what, at least for me, makes being involved in the construction industry so rewarding, is, hey, it's not the same thing day in and day out. no 2 days are alike and no two projects are alike, so each one you kind of have to tailor, this is how we're going to build it, this is how we're going to design it to the particular parameters of that site. So like I said, Champ Clark Bridge has a lot of the same components as any other bridge. It's just about as good an example of some of these components as you could find. So what I was going to do is walk through what goes into a bridge and how we're building it here with some of the information from our plan set to kind of show you guys what I'm talking about. So first off, any bridge is going to have foundations. These transfer the load down from the substructure to the soil, or in our case we're going to bedrock. First question I get when I mention to friends back home in Kansas City is, how do you build underwater? And so I kind of laugh. There's a couple different ways to do it. What we're doing here is called drilled shaft construction, and to kind of grossly oversimplify it, what you do is you take a giant piece of steel, hammer it down to the rock, clean out the mud inside it so you have a watertight thing, and then drill down, in our case, 24 feet into the riverbed to kind of give you that foundation that's founded in rock and then can carry the bridge above it. So one thing that I think is kind of cool is our bridge, going back to the very first project I showed you, that big cable stay bridge in New York City, we actually have larger diameter rock sockets and drilled shafts than even that bridge does. So what might look like a fairly simple bridge on the surface is actually a pretty impressive and complex piece of engineering and construction. So the rock socket is this little piece right here. We'll leave the casing in, fill that with steel and concrete, and then that goes up to right above the water surface. And then right above the water surface, we tie into what's called the substructure. This transfers the load from the superstructure down to the foundations. And on our project, it kind of has three main components. The strut, which connects the two columns down to the shafts. The columns, which basically get you up to the height you need to be to start building above that. And then the cap, which is what the girders rest on. So on top of the substructure, we have the superstructure. Like I said, each project's different. Most bridges today are girder bridges. In our case, we'll have 12-foot deep girders, 4 lines of them across. On top of that, we'll have a deck, which is being precast right here in Missouri. We'll pick those pieces up, put it across the girders once they're in place, and then at the end of the day, put the roadway on and then the barrier, stripe it and open it to traffic, so kind of what you expect to see. After that, a big component of the project is the approaches, how the river bridge ties into the existing highway system, how you obviously get up onto it. We have what we call a Missouri approach coming in from Missouri, where we're actually cutting away. This is a 3D model that our design sub-consultant put together to kind of help us visualize what we're planning on doing. These lines represent kind of the existing hill, and we have to cut that away, build a retaining wall to hold back that hillside, and then fit in the new roadway right next to that so that we can fit it in next to the existing bridge and not disrupt traffic or the economy here in town with an extended closure. On the Illinois approach, we're actually building a pretty significant fill, which means we're trucking in rock material to build up to a higher elevation and help protect the bridge from flooding that was known to occur with the existing structure. So schedule, we've been going on the project since June of this year. MoDOT's obviously been involved a little bit longer, but in June we were awarded the contract to design and build the new bridge, so that's when we started on the design as well. The official groundbreaking for the project was this past September, and that was a pretty cool event to be part of. And since then, we've actually completed our first segment, which, if those of you have driven through the intersection, right on the Missouri side of the bridge, we widened that out, repaved it, put in new curb and gutter, ADA ramps, all that fun stuff. So that was good that we made it through our first milestone. Obviously, we have a lot to go before we open the new bridge to traffic in fall 2019. So we've been going for a few months, kind of where we are now. I figured I'd show you guys some pictures. These were actually just taken yesterday, so MoDOT hasn't even seen them. But what you can see here, obviously the existing bridge, and then we're working on Pier 5 and Pier 4. At Pier 5, we're actually placing the concrete for one of the shafts, and at Pier 4, we're putting, you can't quite see it, but putting the reinforcing steel into that shaft prior to placing the concrete, hopefully next week. We'd already placed the first two shafts at first shaft at each one of those piers. The other thing you can see is that we've cleared out the trees, the underbrush, all that fun stuff on the Illinois approach to both give us access to the river, but also to start building up that embankment that I talked about to tie in on the Illinois side. So here's another picture a little bit closer up. One thing that really worked out well for us here, the riverbed kind of slopes away towards the Illinois side. So the drilled shafts in the water on that side of the river are significantly longer than the drilled shafts on the Missouri side. And because of that, for the shafts in the middle of the river, we have to actually pump the concrete into buckets, ferry that out on a barge, and then place it in the shaft, which is a little bit more time consuming. On the first couple shafts, which were the longest, we were able to figure out a setup where we could pump it from the land, place it more efficiently, and then have more control over kind of the time frame for how long that took us. So I thought this was a cool picture. Kind of shows where we are as a project. We'll continue working up with the substructure columns on 5 as we drill the shafts at 3 and 2. Once those are all at the same height, we'll start setting the girders across the top and then finish up with the superstructure. So that was a quick overview of the project. You'll hear a little bit more about your guys' role in the project from some of the other presenters. One other thing I wanted to touch on before I handed off the clicker was just the construction industry. Hopefully being part of this process makes you think that, hey, this is something I can make a career out of. And some parting words as far as that goes is that it's an incredibly exciting industry. It's one that really needs workers, so there's a lot of opportunities there. There are a bunch of different roles. You could be engineer, project manager, designer, if you want to spend a bit more time outside, superintendents, skilled trade, estimating, all that fun stuff. But the important part here is that all these positions, the overwhelming majority of them are from STEM, STEM-related majors in college, that type of thing. So we recruit heavily in the state of Missouri. Our two largest schools that we feed from are Mizzou and Rolla. And I can tell you if one of you guys in 4 or 5 years says, hey, to the recruiter at the Massman booth at one of those career fairs, I heard about you guys on the Champ Clark project, that would really make them smile, and they'd be really excited to talk to you guys. So with that, I'm going to hand over to Karen Daniels. She'll introduce herself.
Good morning. My name is Karen Daniels. I am a historian, so not involved in the STEM fields, but I work with our engineers because there are a number of environmental and historic preservation laws that MoDOT must comply with in order to build projects like the new Champ Clark Bridge. You're going to hear more about those laws from Keith. But I want to tell you a little bit about the history of the Champ Clark Bridge that's there now. The old Champ Clark Bridge, I guess we're calling it now. Planning for the Champ Clark Bridge really began starting in February of 1926. The Chamber of Commerce here in Louisiana sent a letter to the Chamber of Commerce over in, Pittsfield, thank you. I had it written down. I decided to come up without my notes and try and wing it, and obviously this is not a good idea. So, saying, you know, building a bridge that could unite Illinois' pavement with Missouri's pavement would really help the economy of Illinois, Louisiana, and we could actually take Illinois products all the way to California if we could build a bridge across the Mississippi River here. So, as a result of that correspondence and some meetings, the Missouri-Illinois Bridge Company was formed. They got authorization from the U.S. Congress to build a bridge across the Mississippi River, which was required because it's a navigable riverway. And in October of 1926, construction began. So just a very few months after construction, or after they started planning, construction started, not something that happens today. Construction's 1926, 1927, 1928. Construction actually proceeded fairly normally until a span fell in the river. That was mid-year 1927. I don't remember exactly which span number it was. You'll see photographs of it almost anytime you see pictures of the Champ Clark Bridge during construction. You'll see one down in the river. It is unfortunately because it fell in the river. One man lost his life during it. So the construction trades have always been dangerous, but they have a lot more safety measures in place now than they did back then. But open to traffic in May of 1928, has official dedication in June 1928. The governors of both Missouri and Illinois came to the dedication, as did the mayor of Chicago. Why would the mayor of Chicago come to Louisiana for the dedication of a bridge across the Mississippi River? He expected a lot of Chicago industry to be shipping goods across this bridge. This bridge was built as a toll bridge. Most of the bridges across the Mississippi River at this time were toll bridges. The bridges in St. Louis were toll bridges, the bridge at Keokuk was a toll bridge, the bridge at Quincy was a toll bridge, the bridge at Davenport was a toll bridge. So you had to pay to get across the river, so your best way to save money was to cut miles. Highway 54 was a way to cut the miles between Chicago and points west. So that's why the mayor of Chicago decided to come to Louisiana to attend to the dedication of the Champ Clark Bridge. The bridge was designed by the engineering firm of Harrington, Howard, and Ash. The substructure was built by the Missouri Valley Bridge and Iron Works, and the superstructure was built by the Illinois Steel Company. So that's its construction. I said it was a toll bridge. Missouri-Illinois Toll Company collected tolls until 1934, when unfortunately, due to the Great Depression and decreased traffic and the fact that they just could not collect enough tolls to meet their obligations, and the fact that they had invested money in Wall Street, and like everybody else, their investments crashed along with everybody else's, they declared bankruptcy. And the company went into receivership, and a new company was formed, the Champ Clark Bridge Company. And they collected tolls through the rest of the Great Depression. And in 1941, Pike County, Missouri purchased the bridge. And they then collected the tolls until the debt for the construction of the bridge was paid off in 1952. And in 1952, the state of Illinois and the state of Missouri jointly purchased the bridge from Pike County, Missouri, and we have been maintaining it, the state of Illinois and the state of Missouri, ever since. It was named after Champ Clark, who was a native, well, maybe not a native, I don't remember whether he's native. He was a longtime resident of Bowling Green, who was elected to the U.S. House of Representatives and served as Speaker of the House for many years. He actually came to the dedication ceremony and spoke at the ceremony. So, and he'd been instrumental in championing the crossing here. Before this bridge was constructed, to cross the Mississippi River, you had to cross on a ferry. Ferries can't cross a river when it's iced over, and it was already being used for barge traffic, so there was kind of like trying to cross a highway when there's traffic going the other direction. You had to pay attention to river traffic going this way when you're wanting to take a ferry this way. So a bridge was going to relieve that kind of congestion. You could take the train across, but then you're reliant on train schedules. So, and you know, in 1926, people were buying automobiles. People wanted to have control of their own lives, just like we want to have control of our own lives today. So, this bridge was determined to be eligible for listing on the National Register of Historic Places, which is the nation's list of buildings, structures, objects, sites, and districts that are significant in American history. So this bridge has been determined to have significance in American transportation and American engineering. Because we are removing this bridge as part of our project, we have to do what we call mitigation. It's all part of those federal laws that Keith is going to tell you about, and those federal processes. So we're researching the history of it to get a detailed history of this bridge. And because it is such a major structure and it had such a major impact on especially Louisiana and Pike County, Missouri, and Pike County, Illinois, we want to make sure that the mitigation that we are doing is really commensurate with the impacts that we're having. So you guys are here to help us do that, and you're going to hear more about that from Keith and Brandy, and they're going to tell you about that. And I'll actually kind of explain a little bit more about, probably answer some questions as we go along. So, but thank you for coming and thank you for participating.
So they only gave me one slide because they don't trust me. So, all right, quick quiz. When was the bridge built? What year was it open? 1928. So that makes it how many years old?
A long time.
90. Very good. There's a math guy already. So, 90 years old. The bridge has been around a long time. How many people have been across it? How many people drove across it? So is that a fun experience?
No,
Because why?
because it was the first bridge I drove over.
It's the first bridge you drove over. It's really narrow though, isn't it? It's only 20 foot wide. And when your car is about 6 to 6.5, 7 foot wide. You have a 10-foot lane. You don't want to hit the bridge rail, but yet you don't want to be too close to the yellow line because there's other vehicles. And if you meet a semi on it, you're like, ah, because it can be really nerve-wracking. So when we, as a state DOT, when we come up against projects and we see a need, and this was a need because we were spending a lot of money on keeping the bridge in good condition. A 90-year-old bridge takes a lot of money to keep in good condition. So what we were seeing was we had a need here. We had something that we needed to fix. And so as a State Department of Transportation, we said we need to put a new bridge in. We understand that, but we need to, before we could just go start building a new bridge, we have to decide a few things. What is the actual need here? How are we going to address that need? And what are the items that are important to us when we do this new project? So as you launch into this, what's the problem statement and what are the solutions to the problem, you have to go through this big process called the NEPA process. And that's the National Environmental Policy Act, which was in 1970 enacted by Congress, which is a whole set of rules that says here's what you have to go through when you get ready to do a new project. And we have to go through this process for every project we do. Now the process is much simpler for smaller bridges, or if we're doing a resurfacing job and putting some asphalt down, or if we're doing a signal job and putting signals at an intersection. The process is very simple because the impacts are very small. But when you look at a project like this, the impacts get much larger. Or if we are four-laning a highway, the impacts get much larger. So the scale of what we have to look at changes based on the project size. So for a project of this size, there's a whole bunch of things we have to look at. And these things are what we call resources. And Karen already talked about one resource, which is what? The actual bridge itself. The bridge is considered historic. So that's one resource that we have to think about. What other resources do you think we would have to think about when we're looking at doing a highway project that could be impacted that we would have to think about before we just go out and start building? What's a resource? Yes?
The businesses.
Businesses, that's perfect. We have to look at, are we going to impact any businesses? Are we going to have to buy any businesses and make them relocate? So that certainly would be an impact to the local community that we would have to think about those type of impacts. What other impacts can you think of? Land and environment. Well, man, that's a big one, environment. What things go into environment, do you think?
We've got the ecosystems in the water and outside the water.
Perfect. Ecosystems, the water. So things we have to look at is the actual river itself. The water quality, are we going to make the water quality worse? Are we going to improve the water quality? We have to think about what lives in the water. Are we going to impact mussels? Those are a big thing. I don't know how many of you really think about mussels, but we have to do a mussel study to make sure that if there's a certain type of mussel there, we have to move those mussels, gently pick them up and move them somewhere else and say, live here, because we're gonna drill a big hole right here where you're living, in your living room. So we have to think about that. We have to look at different type of fish species, pallid sturgeon, for instance, that potentially could be important to think about. Are we going to impact them? You mentioned land. We have to think about, are we impacting any unique or prime farmland that might be going out of production and into a different type of use? Transportation now. Are we limiting somebody's ability to make a living? What other impacts can you think of a resource that we would have to look at?
Potential impediment of barges going underneath the bridges.
River traffic? Sure. We have to make sure that what we're constructing is going to be economically viable for those people who have to use the river to get their goods and services up and down. Any others? Nobody? We have the historic thing, remember, that Karen mentioned? So it's not just the bridge, it's not just historic, but we have to look at the buildings on either side of the river. So what building lies on the Missouri side in Louisiana that you think might be historic?
That motel looks like it's been there for 100 years.
That motel has not been there 100 years. It was built, I think, in the
1952.
50s. 1952. So it's not been there 100 years. It's been around, you know, over 60,
That White House.
70.
Yeah, that White House.
But the motel is considered historic because of its architecture is considered unique and different for this area, for the time period that it was built. So when we look at a project, if we decide we have to impact that motel, i.e. tear it down, we say impact, which really means could be at different levels. We build a bridge really close to it,